back when we first learned how to solve equations, we said that there were two big ideas that would always be true, whatever the type of equation. One is you're trying to isolate the variable on one side, and two, whatever you do to one side, you do to the other. The same exact premises are at work when we're solving inequalities. And so the steps and the procedures will be very, very familiar to you. However, there's one major difference, and before I say exactly what that is, I want to explore that whole idea of whatever you do to one side, you do to the other. So let's just say that I'm talking about -4 and -2. We know that -4 is less than 2. On a number line, it would be to the left. It's further from 0, however you think about it. -4 is less than -2. So let's think about this idea of whatever I do to one side, I can do to the other. If I add a positive number to both sides, actually, let's make sure that this would be true no matter what. Okay, so -4 is less than +2. So if I add a positive number to both sides, -2 and 4, it's still true. If I add a negative number to both sides, it's still true. And since addition and subtraction are really the same thing, subtraction is the same as adding the opposite, we've, I think, given a good sense of the fact that if I add the same number to both sides, the inequality remains true. Let's now look at multiplying. -4 is less than 2. If I multiply that entire thing by +2, I get -8. I write -6, even though I say -8. Okay, it is -8 and 4, and clearly that's still true. If I multiply both sides by a negative number, what happens? If I multiply it by -2, this side becomes -8, and this side becomes +8, and this side becomes -4, and clearly that's not the same. It makes it the opposite. And the reason is, when I multiply by a negative, it makes the number go in the opposite direction. If I were to do this same thing and say -4 is less than 2, and just for simplicity's sake, multiplied by -1, when I multiply by -1, I'm taking the opposite of it. And the opposite of -4 is bigger or greater than the opposite of 2. If you think about a number line, where I start out, if this is at -4, -3, -2, -1, 0, 1, 2, 3, okay, so if this is 0, 1, 2, 3, -1, -2, -3, -4. So, if I start here and I multiply by -1, it makes the opposite and it pulls it this way. If I start at 2 and multiply by -1, it goes that way. They reverse. So what we've learned from this is that when I multiply both sides by a negative number, it gives me, hold on, what? Is that what makes the page? Oh, there it is. Sorry. When I multiply by a positive number, nothing changes. But you can see that multiplying by a negative number, okay, now I don't know what's wrong. Multiplying by a negative number flips the sign. The one operation we haven't done yet is division. If I start out with negative 4 again, and I can't remember if I had it was less than, I think it was. But anyway, negative 4 is less than 2. If I divide by a positive number, this gives me negative 2, this gives me 1, still less than. If I take this same problem and I divide by a negative number, again, just like with multiplication, the sign flips. So multiplying by a negative number flips the sign. Dividing by a negative number flips the sign. So in general, when solving inequalities, follow all of the steps of solving equations, except remember to pay attention to when you are multiplying or dividing by a negative number. Now in each of these problems, you're also always going to be asked. So let's take a look at what that looks like. If I say m minus 9 is greater than 2, I'm going to try to isolate the variable, use the opposite operation. Whatever I do to one side, I have to do to the other. I've isolated m. Have I multiplied or divided by a negative number? No. So the sign remains the same. Now I go to my graph. The thing that we don't have in a video yet is this whole idea of greater than or equal to, less than or equal to. These two signs without the or equal to are open dots. These are closed because if it's greater than, actually let's make this greater than or equal to. M is greater than or equal to 11. Closed dots, because let's take this example. If this is 11, we know it's all of the numbers that are greater than 11. But it can also be 11. So 11 needs to be included. If instead it said m is greater than 11, then m is not a part of the solution set. And therefore, I draw my little dot at 11, but it doesn't include 11, so I have to make the sign open because it's only greater than 11. So it's all these numbers starting here, just outside of 11, and going to the right. And here's a little trick. If your variable is on the left, your line will extend in the direction that the inequality symbol is pointing. So that's how you would solve and graph that. This one is m is greater than 11. This one is m is greater than or equal to 11. When the variable is on the left, this one, the lines go to the right, and this one, the lines go to the left. Here, if I have negative 8x equals, oh sorry, can't be equals, we're doing inequalities. Negative 8x is greater than 16. So to get x alone, I use the opposite operation, and I always need to ask myself, have I multiplied or divided by a negative number? And the answer is yes. Therefore, 16 divided by negative 8 is negative 2, but my inequality flips because I've divided by a negative number. And when I go to graph that, I graph the negative 2. It is not including negative 2 because it's less than, so I make it an open dot, and I draw my arrow to the left. On the other hand, just to be really clear about this, if negative 8x, if 8x was greater than negative 16, it's almost the same problem. In this problem, though, I'm dividing by 8. Since I'm dividing by a positive number, my sign doesn't flip. It's only what you're dividing by or multiplying by. So x is greater than negative 2. And this means that since x is on the left, I'm going to again do an open dot at -2, but this time it's all the numbers greater than, and that goes to the right. Just one more example, things up a little bit more. If I say 6x minus 3 is less than 7 plus 4x. My variables on both sides. We've always known, since we've learned this, that we just want to get all of the variables on one side and all of the constants on the other, and it really doesn't matter which way. However, in inequalities, solving inequalities, I strongly suggest that you bring the variables to the left side and the constants to the right, because then you have your handy-dandy variable on the left, which means the inequality is going to go in that direction. X is less than 5. Did I divide by a negative number? No, I didn't. You have to ask yourself that all the time. It's so easy to forget. So open dot on 5, and I'm going to go to the left. Notice x is less than 5 is the same as 5 is greater than x. If you were to do it the other way and find out it was like this, I think it's easier to rewrite this, put your variable here. If the point is going toward the variable, it still has to go toward the variable because the small side always goes to the small number if that's what that is. So in other words, I would transform it to this so that your variable works. Just one other thing about the homework assignments. If we were solving an equation and we got, I don't know, 8 equals 8. Does 8 equal 8? Yes, it does. Or this would have been an identity, and an identity means infinite solutions because any number works. In inequalities, if I say 9 is greater than 8, is 9 greater than 8? Absolutely. It's a true statement. So this is like an identity in inequalities, and it means that any number would work. Therefore, it's the whole number line. Okie dokie. Don't forget, always make sure to watch out for multiplying or dividing by a negative number.